Hello and welcome to this episode of Math with Martinez. In today's video, I'm going to be teaching you all how to simplify monomial expressions. That's what we're going to see on this first page. And also to classify polynomial expressions by both the degree, as you can see here, and the number of terms as well. So let's go ahead and begin with simplifying monomial expressions. What is a monomial? Let's begin there. A monomial is a number, a variable, or a product of numbers and variables. For example, we could have a monomial that looks like just the number 4. That's an example of a monomial. Mono meaning single, and nomial, meaning like number or expression. So 4 is a single expression. 7x is a single expression. And 3x squared is also an example of a monomial, just a single term. You could think of it like that, a single term. A monomial is just one term. And when we're working with monomials, we will be using exponent rules to simplify. That's one of our learning goals here, is to simplify monomial expressions using these rules down below. So let's go ahead and begin with these rules. The first rule is called the product rule. It says that if you have the same base, so like a base of a times a, but they're raised to different powers, then what we end up doing is just adding the powers together. Adding the powers. So if we had x squared times x to the 7th, then that would be x to what power? Well, by adding them together, that gives us 9. So the product rule says if you're taking the product, meaning multiplying, the same bases, you add the exponents. The power rule applies when you have a power, like a to the nth power raised to another power. In that case, then you're going to go ahead and multiply your powers together. So if we had x squared and then that was raised to the 7th power, then we would simplify this as x to what power, you guys? That would be, when multiplied, to the power of 14. That is the power rule. A power raised to a power. Make sure that you multiply them. Now the quotient rule, quotient means that we're taking the same bases raised to different powers, and we are dividing them. If that is true, when we were multiplying the same bases, we added. If we're dividing, then, ladies and gentlemen, I think you might see that it makes sense that we subtract. So if we had x to the 7th over x squared, then this would simplify to, go ahead and subtract, power of 5. Now the negative exponent rule, we're going to use a whole lot all throughout this unit, but on through your studies in mathematics, because we never want to leave a negative exponent in our answers. It is not like mathematically proper grammar. So if you have a negative exponent, it may be rewritten. Let me back up just a little bit. Let's say we have a to the negative m power over a number, like let's say divided by 2. Then the way that we would write this would be to bring that base into the other location in your fraction. So if it was in the numerator, into your denominator, and make the power positive. And that would mean that we would have a 1 left in the numerator. So if you had x, let's even write it like this, to the negative 2 power, is that in the numerator or in the denominator right now? Technically, that is over an understood 1. And so when we rewrite this, it's going to come down into the denominator. It's going to be now a positive exponent. And that 1 would be in the numerator. You've got to have that fact that there was an understood 1 even in front, and that's what you're seeing here. And the last rule that we have is the 0 exponent rule, which says that anything raised to the 0 power is always 1. So if I had even something as complex as this, 7x squared, raise that to the 0 power. Well, since all of that is being raised to the 0 power, it simplifies to 1. So that, ladies and gentlemen, is going to be essential if we're going to simplify monomial expressions like we see in these couple examples. So let's go ahead and begin. When we have this first example, I've got a monomial here, right? I've got this monomial multiplying with this monomial. And so what we do is we go ahead and we can think about rewriting this 5 times, I'm going to put it in parentheses because that looks better, negative 7. And then that's x squared times x to the 6. I've just rewritten this using my commutative property of multiplication. Now the 5 times that negative 7, that's going to be a negative 35. And then which property do we need to use here? Which one of our properties needs to be used to simplify the x squared times x to the 6th? That's going to be our product rule. And applying our product rule, because those same bases we're multiplying, we're going to add the exponents. And so that, ladies and gentlemen, would be my final answer. I only have one variable. I only have my variable one time is what I'm trying to say. Let me contrast that here with example number 2, because in example number 2, I have several variables. So I'll want to rewrite it so that I only have A raised to a certain power just one time and B raised to that certain power one time. But let's go ahead and begin. I need to begin by taking care of the fact that this has all been raised, all of this, to the second power. So what that means is I need to take negative 2 and square it. I need to kind of distribute that power to everything inside. Negative 2 when squared is 4. My a to the 3rd then squared, that means I'm going to need to multiply those powers using that power rule that you see here at the top of the screen. And then I have my b raised to the second power, which will just be b to the second power because it was b to the first power. Then that is being multiplied with 8ab to the 9th. Like we did before, we're going to want to go ahead and multiply the number portion, the 4 and the 8, which is a 32. I have a to the 6th being multiplied with a to the 1st. And so that is once again an example of our product rule. I need to take a, add those so it is to the 7th. Again, my application of the product rule, because I have b squared and b9, that simplifies to b to the 11th. All right, a little bit more here. Let's look and see. When adding or subtracting monomials, we must make sure that we combine like terms. First, let's see if we can simplify this a little bit. I've got 54 divided by 3. 54 divided by 3 is going to be 18. And then when I focus in here on my m to the 6th over m squared, that is an application of my quotient rule. I need to subtract those exponents. So that's going to be m to the 4th. And then n to the 3rd, right, that's the next little piece right here, is going to be the result because 4 minus the 1 in the bottom, that's going to give me n to the 3rd. And then minus 10, m4, n3. Now, do you notice that these two terms both have the same variables and those variables are raised to the same exponents? That means I have 18 of those items minus 10 of those items, which simplifies to just 8. M4, N3. All right. So last but not least, let's go ahead and look at example 4. I've got the 2 and the 10, which I multiply together to give me 20. And then I have a k4 and a k to the negative 7. They're multiplying, so I need to go ahead and subtract. I'm sorry, well, it's kind of like subtracting, but I'm adding, right? I'm taking and applying that product rule, but I'm adding a negative 7. So when I do that, 4 minus a negative 7 is going to be k to the negative 3 power. Now, like I said, we cannot keep that negative power in our final answer. We're going to need to relocate it to the denominator. And once I do that, it is then positive. So those were our examples where we were looking to simplify monomial expressions. Now let's turn the page and look at polynomials. Now a polynomial, to define that, is just the sum or the difference of many monomials. And the highest exponent of your polynomial is called the degree. That is called the degree of your polynomial. Now, standard form is how we will always write our answers. So we will always write with exponents in descending order. Which means largest to smallest. So for example, if we were going to rewrite this, we would want to go ahead and look for the term with the largest power. So the one with the largest power is right here, this power of 5. So we would start there and we would say negative k to the 5th power. Boom, done with that one. Now, do I have anything to the 4th power? Nope. Okay, how about to the 3rd power? Yep, there it is. Negative 3k to the 3rd. And then I have that power of 2. And then when I have just k, 8k to the 1st power, but we never write that 1 in there, right? It's an understood power of 1. And then no powers, the one with no variable at the very end. Now, we're typically going to have our polynomials like so with just the single variable, but if you had 2 variables, then you'd want to begin alphabetically. So look for the largest power of a, since our variables are a and b. The largest power of a is 4a cubed to the 3rd power. Now let's see. Then look for when a is squared. Oh, there it is. A squared. And then that b is also there. All right. And then keep going with that variable a, right? So we started with a cubed, a squared. Now do I just have a? An a, yes, right here. That is 7ab. And then lastly, our final term there, which is minus the b squared. But it has no a in it at all. So that's how you decide the order to put those in. All right, so looking here at this last one, let's look and see. We've got x and y. So we're going to go based on the x. Where do we have my largest power of x? This one only has 1, 2. Oh, there. That one is the largest. So we're going to put 9x cubed y first. Not to be confused with this one. Yes, that has the highest degree. That's the highest degree term, but it's not for the letter that came first in the alphabet. So make sure you follow your alphabet. Okay, now do I have any x squares? X squares, yes. Minus x squared. And then just x by itself. Yep, that's a positive 5xy squared. Okay, and then I'll put that minus y to the fourth. And then last of all, the number that has no variable at all. Now, one of our main goals here was to be able to classify by degree the polynomials, but not only by degree, also by the number of terms. So we're going to fill in this chart over here on the side so that you can see the ways to classify. It's like giving your polynomial a first and a last name. So the first name is based on its degree, like we saw up here, based on the highest exponent. Based on the highest exponent. So if you have 0 exponents, that is called a constant. If you have at most a variable, but its power is only 1, its degree is only 1, that is called linear. If its degree is 2, it's called quadratic. A degree of 3 is cubic. A degree of 4 is quartic. And a degree of 5 is called quintic. Anything above that we just call degree 6, degree 7, and so on and so forth. But that is not the only way. We also do give them a last name, and it's based on the number of terms. If you have 1 term, it's called a monomial. 2 terms is called a binomial. 3 terms is called a trinomial. But if you have more than 3, if you have 4 or more, then it's just called a polynomial. So let's go ahead and begin to identify what we would classify each of these as. So let's begin with their degree. Let's look at the power, the highest power that we've got here. So this is my term with the highest power. It's just an x, maybe with an understood power of 1, a degree of 1. Because of that, it is first name is linear. And then let's count out the number of terms. 1, 2. 2 terms is called, if you have 2 terms separated by either addition or subtracting, then that is last name binomial. This is, in example 13, a linear binomial. All right, now let's look at 14. The leading term here is the one with the highest power. It has a power of 5. So because it is a power of 5, that is called a quintic. A quintic, now based on the number of terms, last name will be a trinomial. because there are 3 terms in our polynomial. All right, well, this one is kind of interesting because we only have 1 term and there are no variables. So what that means is that because there are no variables, the degree is 0, so this is a constant. This is a constant, no power, no degree at all. And there is only the 1 term, so it is a constant monomial. All right, we're rocking and rolling here. Let's look now at example 16. Example 16, what would be its first name based on this first term? Because its power is 3, it is cubic. And what would be its last name based on the number of terms? 1, 2, 3, 4 terms. Anything with 4 or more is just called a polynomial. All right. What is going to be the complete name for example 17? What would we call that? Based first on its degree and then on its number of terms. Well, it is squared. It's squared, so that's quadratic. And there are 1, 2, 3 terms, so it is a trinomial. 18 is kind of unique here. You don't see this a whole lot. I like it. The power or the degree is 4, so it is a quartic. And there is just the 1 term, so it is a monomial. Now let's give an example of a cubic binomial. Cubic binomial. So because it's cubic, cubic means it's going to have a power of 3, and binomial means that there should be 2 terms. 2 terms. So we want to begin by having 2 different terms. Let's pick a variable. I'm just going to go with x. So maybe x cubed, and then I need 1 more term, so maybe minus 9. The highest power is a power of 3, right? The highest power is a power of 3, making it cubic, and then we have our 2 terms, 1, 2, binomial, cubic binomial. Now, let's look at this final example. Let's give an example of a linear monomial. Linear monomial. Linear means power of 1. Monomial means just 1 term. Okay, power of 1, power of 1. That's like what we saw here in example 13, but that was a binomial. So if I want it to be a linear monomial, maybe I just write it like this. Negative 3x. Single term, there's only 1 term, and that x is raised to an understood 1, but we don't need to write it. Ladies and gentlemen, that is classifying polynomials by both their degree and the number of terms. We've taken care of both of our learning goals now. I hope that you all enjoyed that it was very instructive and informative. If you have any questions, will you please take a moment to share those now? And until next time, stay fired up.